By the name of God, the most merciful, most kind, peace be upon you all. We are going to talk about post number 4, or the fourth video. We want to derive an expression for lower and upper matrices for 3 by 3 matrix. L stands for the lower matrix and U stands for the upper matrix. We are going to use Doolittle's method. And here is the difference between the Doolittle's method and the Kraut's method. It's writing that it is possible to show that for any square matrix that can be expressed as a product of lower matrix L and an upper matrix U, but in the case that it is invertible. The procedure based on the unity element on the major diagonal of L is called the Doolittle method. The Doolittle method, in which we have the lower matrix with 1, 1, 1, the diagonal in the case of 3 by 3, while the procedure based on the unity elements on the major diagonal U is called the Kraut's method, for which we have U11, U sub 22, U sub 33 equals to 1. This is the Kraut. We move to the next slide. We have Doolittle's method. Let us consider the A matrix, which is A sub 1, 1, A sub 1, 2, A sub 1, 3 for the first row, A sub 2, 1, A sub 2, 2, A sub 2, 3, and for the last third row, A sub 3, 1, A sub 3, 2, and A sub 3, 3. We are saying that we will multiply L by U, and it is equal to A. Here is our L based on the Doolittles. We have a diagonal x equal to 1, and this is a lower matrix for which the upper elements are zeros. Let us call in the second row L sub 2, 1, and for the third row we have two elements L sub 3, 1, L sub 3, 2. If we move to the upper matrix, we have U sub 1, 1, U sub 1, 2, U sub 1, 3 for the first row, while for the second row we have 0, U sub 2, 2, and U sub 2, 3. For the third row we have 0, 0, U sub 3, 3. We are going to multiply the L by U and equate the product to the matrix A, and trying to find out the values for the L and U matrix. How many unknowns we need to get values? We have 3 for the lower matrix, while for the upper matrix we have 3 plus 2 plus 1, we have 6. We'll move to the next slide. After we multiply the L by U, we get that expression. But let us review our information regarding elementary matrix. This is the L and this is the U. This 1, 0, 0, there is no change in the U11, U12, U13, because if we assume that this is an identity matrix, the first row in the identity matrix is 1, 0, 0, 0. So this row, after we multiply, there is no change. Here is L sub to 1, 1, and 0. This L sub to 1 is nothing but multiplying the first row by L to 1 and add to the second row. So try to get the second row for the product. L sub to 1 multiplied by U11 added to 0 is here. L sub to 1 multiplied by U12 and add to U22 is here. And L sub to 1 multiplied by U13 added to U23 is here. If we move to the third row of the lower matrix, we have L31 multiplied by row 1 and added to row 3. So we have L31 U11 plus 0 is here. L31 multiplied by 0 is 0. So we have nothing added. We add to L32. So L31 multiplied by U12 added to 0. While we have L32, which is the product of L32 by the second row added to the third row. L32 by U22 added to 0. This is this term. And the last term is L31 by U13 is here. This is U33. And L32 multiplied by the second row U23 is here. We are going to equate the corresponding elements, such as for the first row we have 3 elements, and the corresponding elements for the first row in matrix A are A sub 1, 1, A sub 1, 2, A sub 1, 3. We'll move to the next slide. Equating U11 to A11, and U12 to A12, and U13 to A13, as we can see. Once we have obtained the values of U11, the next step is to get the value of L sub to 1. We have L sub to 1 multiplied by U11 equal to A21. We have obtained already the U11 is equal to A11. So we are going to divide A21 by A11 to get L sub to 1. So L sub to 1 is nothing but A21 over A11. A21 divided by A11 will give L sub to 1. While for L sub 31, we have L31 U11 equal to A31. If we divide by the value again of U11, which is A sub 11, we can get the value of L sub 31. L sub 31 equal to A31 over A11. As if we divide, this is a pivot, we are dividing A31 over A sub 11. We move to the next slide. We come to the second row, second column. We have L sub 1 multiplied by U12 plus U22. And the second row, second column for matrix A is nothing but A sub 22. We have L sub to 1 as equal to A sub to 1 over A sub 11. Then L sub to 1 by U12 plus U22 equal to A22, but already L to 1 is A21 over A11, and U12 is nothing but A12. So we can get an expression for U sub 22 as equal to A sub 22 minus A sub to 1 over A11 by A12. We move to the second row, third column element, L sub to 1 U13 plus U23 equal to A23. We get the value of U23 as equal to A23 minus L21 by U13. L21 again, A21 over A11, and U13 is A13. We move to the third row, second column, L31 U12 plus L32 U22 equal to A32. And we use the data that we have U11 equal to A11, U12 equal to A12, and U13 equal to A13. So for the L sub 31, we have it as equal to A31 over A11. We multiply by U12, which is A12, plus L32 by U22. U22 already we have as equal to A22 minus A21 over A11 by A12 equal to A32. Then this is the expression of L32 equal to A32 minus A31 over A11 by A12 divided by A22 minus A21 over A11 A12. Next, for this element, L31 U13 plus L32 U23 plus U33 equal to A33. Again, we want to get the value of U33. This is nothing but A33 minus A31 A13 divided by A11 minus L32 U23 minus A31 over A11 by A13. Now we can write the elements that exist on the lower matrix as we have the diagonal equal to 1 because we are using the Doolittle's method. This is A21 over A11 and A31 over A11, and this is A32 minus A31 over A11 by A11 divided by A22 minus A21 over A11 by A12. This is a lower matrix. We need to find L32 to create by creating U1 matrix. Let us see what is U1 matrix. This is the U matrix A11, A12, A13. We need these two elements to become 0 by multiplying minus A21, A11 by the first row adding to the second row. And we divide A31 by A11 multiplied by minus 1 first row and add to the third row. Due to these two operations, we have two zeros, and we have a change here in the second row, second column, that this element is A22 minus A21 over A11 by A12, and this element change it into A23 minus A21 over A11 by A13, and the third element has been changed. This is 0, and this element is A32 minus A31 over A11 by A12, and this element A33 minus A31 over A11 multiplied by A13. We use this as a pivot, and we divide this by this element. We multiply in the second row to get the value of L32. This is a procedure adapted from the elementary linear algebra book by Bernard Coleman that we can create side by side L1 and U1. This L1 is nothing but diagonal y in 1 and A21 over A11. This is the L21, and L31 is A31 over A11, and this is unknown. You will come to know this value after we make this pivot and we divide this. We use this as a pivot, and we divide A32 minus A31 over A11, A12 by minus R2 in order to eliminate, to make this 0. Once we have done this operation, we change the sign and put it here as a value of L32. And then we move to the U33 value later on. It's better in the next slide, in the next video, we are going to apply for practice problem in order to implement all these elements values and to find out how can we constitute L1 and U1 matrices. Thanks a lot. God bless you all, and goodbye.